I went 15 minutes and 10 seconds before I realized it. I hope that I don't have to repeat that. So anyway, here we are at limit as x approaches 1. It's asking what is the limit as x approaches 1, and if it doesn't have a limit, why not? Well, the why not part is because the right and left hand limits are not the same. That's the why not. It doesn't have a limit. Is f continuous at x equals -1? And we can use this same drawing. We can see clearly that the function is continuous at x equals -1 because the limit exists, the function exists at -1, and then also the function is the same as the limit at -1. And so, you know what? Let me erase this stuff in the middle, and I'll get right back to you. Let's continue here. I just figured that I would remind you of what it means for f of x to be continuous at x equals some constant. And f of x is only continuous at a constant if the three conditions are met. The only three conditions that need to be met are f of x, the limit as x approaches c of f of x must exist. F of c has to exist, and then the two values that you get in the first two here have to be the same. So I wrote down here that f of x is continuous at x equals -1 because all three conditions are met. Okay, the limit as x approaches -1 exists, f of -1 exists, and they are the same. You can see that. But on the other hand, f of x is not continuous at x equals 0 because the limit as x approaches 0 does not equal the value of the function. We'd say, so we could say the limit as x approaches 0 of f of x equals 0, and that's not equal to f of 0, which is equal to 1. Okay, so 0 does not equal 1, so therefore the limit does not equal the value of the function. On the other hand, the f of x is not continuous at x equals 1 because the limit doesn't even exist, because the limit as x approaches 1 of f of x does not exist. You don't have to go past that. That's it. Okay, so that's 29c. And what do we have next? We have 30, and this was taking a long time to write down, so what I'm going to do here is I'm going to show you how to actually solve these problems without having to graph the function, because I don't want to have to graph the absolute value of x cubed minus 4x. So the limit as x approaches 1 from the left, we just have to look at the function. The first piece is when x is less than 1. So when x is less than 1, that's this guy right here, 1 from the left. And so we just use the piece absolute value of x cubed minus 4 times x. Okay, and so the absolute value of 1 minus 4 is -3. So the absolute value of -3 is 3. So that's the limit as x approaches 1 from the left, because you have to use the top piece of the piecewise function because x is less than 1. The domain restriction says you have to use the top piece when x is less than 1, and that's what this says right here. X is less than 1. X is approaching 1, but from the left, so less than 1. Now, the right-hand limit of f of x, now we have to use the bottom piece. And the bottom piece is that quadratic function, 1 squared, or x squared, but I'm going to put a 1 in for x. Okay, minus 2 times 1, and then minus 2. Okay, well, what's that? 1 squared is 1, minus 2 minus 2. So we have 1 minus 2 is -1, -1 minus 2 is -3. Okay, well, clearly the right and left hand limits don't agree, but let me just be consistent here and say, all right, well, x is, to show you that x, when x is approaching 1 from the right, that is indicating that x is greater than 1, and that shows us that we're going to use that bottom piece. Okay, and so what does this say here? X is approaching, what in the world does that say? Find the right and left, find the right and left hand limits. I don't know why I wrote this down. I'll erase that thing. Right and left hand limits of f at -1. Does f have a limit as x approaches 1? So therefore we would say the limit as x approaches 1 of f of x does not exist, because the right and left hand limits are not the same. Okay. At what points is f continuous? Well, f is continuous. We can see the limit doesn't exist. So f is continuous for all values of x, for all. That's what that upside down capital A represents. For all values of x that are not equal to 1, because x can't be continuous if the limit doesn't exist at 1. So all real numbers except for 1, you can write it in terms of interval notation if you like, or you can just write all real numbers except for 1. And then part C, oh, that was part C. So part C, what is part B then? Does x have a limit? No, so that's part B right there. Okay, let me just fix that. Part B does not exist. I already gave you the reason for that. Now part C is that guy, so where is f continuous? And at what points is f discontinuous? Well, at x equals 1. Alright, we get that taken care of. Number 39, f of x, you can see, is this piecewise function. We want to figure out what value should be assigned to k so that the function is continuous. We had this on one of our last couple quizzes. We know that f is continuous when the limit exists. So let's find the limit as x approaches 3. So 3 is the connecting point. That's the key here. This function here is continuous for all values of x other than 3. And then this function here, this is just a constant assigned to this function when x is equal to 3. So the limit is going to be, let's see, of f of x as x approaches 3 is just a 3 in place of the x. Now, if we put a 3 in place of the x in this rational piece of the function, then we're going to get 0 over 0. So let's go ahead and factor this. Let's see here. Do we have purple yet? So we have the limit as x approaches 3 of factoring the numerator x plus 5 times x minus 3. Now, if you ever want a clue on how to factor a rational expression, just look at one of the other, like if you just look at this denominator, you're pretty sure that this denominator is going to be one of the factors up above. So x minus 3, we get to cancel that, and then we just get equal to 3 plus 5, which is 8. So the limit is 8. Okay, well, the limit exists, and then the value of the function then needs to be the same as the limit. And so f of 3, let me write this like this, f of 3 is equal to k, but k must be equal to 8. So there, k has to equal 8. That's it. That's the value of k. K has to be for this function to be continuous at x equals 3. Problem 40 really is the same concept. So if you didn't know how to do number 39 and you just watch number 39, I would encourage you to try number 40 without watching it first, see if you can figure it out. We want the limit to be equal to the value of the function. So all we have to do is find the limit as x approaches 0. And the limit of f of x as x approaches 0 is the limit of sine of x over 2x. Well, obviously if you plug 0 in, you're going to get 0 over 0. But if you remember the limit as x approaches 0 of the sine of x over x, that's 1. And we could factor out that 1/2. So here's the idea. Factor out the 1/2, and so then you just get the 1/2 times the sine of x over x. And again, if you remember, sine of x over x goes to goes to 1 as x approaches 0. And so what you really get here is 1/2 times 1, which is just 1/2. So if the limit is 1/2, then basically you've got this function. Let me see if I can do this here. So if x, basically if the limit is 1/2, and so here's 1 here, and it really doesn't matter what the graph looks like, but it's probably something like that. It goes up like that. But anyway, there's 1/2 as the limit, and then f of x is equal to k. So in other words, f of 0 is equal to k. Well, what does the k have to be for this function to be continuous? Well, the k has to be the same as the value of the limit, which is 1/2. And so therefore, k must be equal to 1/2. So just like the last problem. Alright, let's see if I can squeeze in another problem here. How many more do we have? 3 more. I don't think I can do the 3 more in 4 minutes, but maybe we can. Number 43, it's getting dark here in my car. I'm sitting out here at the park. Find the average rate of change of this function from 0 to pi over 2. The average value of the function. Well, the average value of the function, if we draw a graph of this, we've got f of 0. So at the beginning of this, oh, here comes my son, so you might hear his voice in the background. F of 0 is 1 plus sine of 0. Well, that's 1 plus 0, or 1. So f of 0 is 1. So we have this function that right there, we don't know really what it, well, I guess we do kind of know what it looks like. It looks like this, right? So if we draw the graph, it's going to look something like that. Because it's sine of x scooted up 1, so 1 unit up from regular sine of x. Regular sine of x is down here, like that. Alright, well anyway, we know that f of 0 is 1, and then f of pi over 2, where is pi over 2? Right there. And that has a value of 2. So, not 1, 2. So, if we were to draw a line through these 2 points, basically the slope of that line, let me move that, okay, go back to that. The slope of the line is the average rate of change. And so we could, if we think about it as the slope of a line, and it's basically f of pi over 2 minus f of 0 over the length of the interval. Okay? And f of pi over 2 is 2, f of 0 is 1, interval is pi over 2 minus 0. So basically we have 1 divided by pi over 2, which is 2 over pi. And we're going to stop for now, and I'll cover the last two in the last video.